We're still dealing with systems of equations, which is just two or more equations put together. And before elimination, we also had two different ways to solve these, and that was by graphing. And we looked at their intersection, and if they didn't have an intersection, then no solution. If they were the same line, infinite many solutions, and if they crossed, the answer was that point right there. Substitution, we got an x or a y value all by itself and plugged it into the other equation, solved for one of the variables, plugged it back in, right? That was our other one. And then elimination is what we've been doing all week, where we try and match a couple variables or get them to be opposite, and then we add them so we totally eliminate a variable, plug it back in, right? So we have three different ways to solve these, right? So let's just get into our special cases for today. When we are looking at this one, again, we want these to either match or be opposite. You can do them however you like. Personally, I like to add, so I'm going to multiply this top one by -3. That way, when I add it, they can go away. But you can multiply it by 3 and then subtract it, whatever you want to do. So if we multiply that by 3, or -3, we get negative 15x minus 9y equals negative 156. And then we can just rewrite this one, 15x plus 9y equals 54. Now when we add it, we'll see why this is a special case, right? Because when we add these, negative 15x plus 15x cancels, and so does negative 9y plus 9y. So what's really left on this side is 0, right? And then on this side, we have negative 156 plus 54. That's going to leave us with negative 102, right? And this obviously is not true. 0 does not equal negative 102, right? So what we're going to have here is no solution, right? And basically, again, if we were to graph these, what this would mean on a graph is that we had two lines with the same slope, which we can kind of see here, right? Because these x's and y's are proportional. They had, I don't know, the same slope, but different y-intercepts, right? So that's what that would mean. They never cross, so there's no solution, because 0 does not equal negative 102. That doesn't make sense, so no solution. Moving on to this one. This is one of the ones where we're going to have to multiply both of these equations. I think if I multiply this first one by 5 and the second one by 2, then I'm going to get these x's to match, right? 5 times 2 is 10, and 2 times -5 is -10, so those will match. If I rewrite this one over here, 5 times 2x is 10x, 5 times 4y is 20y, equals 5 times 12 is 60. And then here, if I do this one, 2 times -5 is -10x, times -10y is -20y, and then times -30 is -60. Now when we add these, 10x minus 10x cancels, 20y minus 20y cancels, so we get 0 again. But we have to be careful. 60 minus 60 also cancels, right? So we get 0 equals 0, which is just true. And so what this is really telling us is that no matter what we put in, this means we're going to have an infinite number of solutions. Because there's going to be a bunch of different x and y pairs that we can put together that'll get us 0 equals 0, right? Because this 0 equals 0 is always true. Now, this doesn't mean that you can pick any x value and any y value. Really, the answers are all going to be on the same line. It's going to be an infinite amount of pairs, right, on a line, right? Because graphically, what this means is, one of the lines is like this, And then the other line is also just right on top of it, the same line, right? That's what that means. If both lines are the same line, then all of these points on this line, which is an infinite number of points, it goes on forever both ways, will be true. But you can't pick a point out here to be true, right? So really, I think a better way to put it is, maybe if you pick an x value, right, and then you plug it in and you get a y value, that's going to be a point. Any x value you plug in, you can get a y value out, and that will be a point that satisfies this. Okay, let's do a couple more. This one I'm going to multiply by -3. Again, I like to multiply by the negative so I can add later. But if you'd rather multiply by a positive and subtract, that's totally good too. Actually, let's do that. Let's actually do it that way since I did it the other way already. Or since I already did it the negative way. So let's just multiply by 3 and subtract. Okay, so if I multiply by 3, that's going to change. 3 times 2x is 6x. 3 times 3y is 9y. And 3 times 5 is 15. All right, and I can rewrite this one. 6x plus 9y equals 15. And we're going to get a similar thing, right? If we subtract these, 6x minus 6x cancels. 9y minus 9y cancels. Equals 15 to minus 15 cancels. And it's the same thing, right? There's an infinite amount of solutions. Not just any point, but an infinite amount of points. Satisfy that. Okay. Now this one, same deal. We're going to kind of have to multiply both here. I think if I multiply this one by 2 and this one by 5, I'll get the y's to, or the x's to match. Right? 2 times 5x is 10x plus 30y equals negative 48. And then this one, if I multiply everything by 5, 5 times negative 2x is negative 10x. 5 times negative 6y is negative 30y, and we kind of see it happening again. And 5 times 28, well, 5 times 20 is going to be 100. And then 5 times 8 is going to be 40, so 140. And if we add these, 10 minus 10x is 0. 30y minus 30y is 0. And then we get negative 48 plus 140, which is going to be 92. And obviously, 0 does not equal 92. So again, we get that there are no solutions.